Okay, so we've got a question here that gives us an isosceles triangle, which is telling us that that length is the same as that length, and it's asking us to work out the area of the triangle. So there's our trigger, and therefore we should be writing down the formula for the area. The area is going to be a half times the base length times the height, where we recognise that the base length is the distance there, which they've given us as 12. So all we need is the perpendicular height. So if we add onto this picture what's going on, then we can see that we need this number here. Well, we should be able to recognise we're dealing with a right angle triangle. We've got an angle, we need a length, and we know that the length from here to here, well, isosceles means that this is a line of symmetry, so this will have a length of 6 centimetres. So we're dealing with a right angle triangle where the information tells us that that's 6 centimetres. We need to know that. There's the right angle, and we know this angle is 54 degrees. When we're dealing with a right angle triangle, again, it's this idea of checking whether we think it's going to be Pythagoras or it's going to be trigonometry. And in this example, because we're dealing with an angle, it's going to be trigonometry. So, Toa. So that's the kind of way we work with right angle triangles. We think about the three ratios for trigonometry, which is sine, cosine and tangent, and then we go through labelling up the triangle. So the angle's here, so the opposite side will be there. The hypotenuse is always the longest side, so that's going to be the h, and this will be the a, the adjacent side next to there. So we go through here asking ourselves, well, what do we need? Well, we need O, so we tick under O. So that doesn't involve O at all, so we can't use cosine. And what do we know? Well, we know the value of A. We don't know H, so that one's gone as well. So now we know that we're going to be using this ratio here. So again, it's a ratio, so write down tan theta equals O divided by A, the opposite length divided by the adjacent length, and theta is the angle. Fill in this with the information we know. So we know that the angle is 54 degrees. O is our question mark, and A we've been told is 6. I need to know what the question mark is, so I rearrange this. So the question mark is going to be, well, this says divide by 6, so the 6 will come here as a times. So we know the question mark is going to be 6 times the tangent of 54 degrees. So we basically got to make sure our calculator has deg in the screen, or the letter D, to make sure we're working in degrees. So yeah, this one is in degrees. So 6 times the tangent of 54 equals. So again, as always, write down the whole of the number on the calculator. So 8.258291523 centimetres. That's going to be the height of the triangle. So now we can go back to our formula, because the question wanted us to work out the area. So the area is going to equal a half times the base length, which was 12, times the height. So we had to times by that height. Now, because I was sensible and left in the number for the height in the calculator already, then I can now times that by 12, and I can now times that by a half, which is 0.5, and that gives me an answer of 49.549. Now I don't need to go much further than that, because I've recognised in the question it asked me for 3 significant figures, and because it asked me for 3 significant figures, then I count 1, 2, 3. Always start with the first non-zero digit, so 1, 2, 3. So I'm going to cut the number here. 4 is less than 5, so it's less than halfway up to that one, so it stays as 49.5. So the final answer here is going to be 49.5 square centimetres. So again, we check the way the question looked. It asked us to work with an isosceles triangle. We could split that by the line of symmetry to make right angle triangle. We recognise from a right angle triangle we could use the idea of SOHCAHTOA, trigonometry. We identified the correct ratio by identifying what we need and what we know, and we then write out the ratio, substitute the numbers in, rearrange, use the formula for the area of the triangle, round it to 3 significant figures as the question asked, and write down the final answer. So that's how we can solve a problem using trigonometry.